Hello folks, you're welcome once again to another fascinating math video. In this video, we shall be considering the rationalization of a general surdic expression. Before we go over to the solution of the problem on the board, I would like to add that I offer an online math tutoring service, both for the primary level, secondary, and even to the college level. So if you're in need of this service, be very free to get across to me because I have an experience that spans over a decade in tutoring mathematics, tutoring different students from the primary to the college level. So be very free to get across to me if you're in need of this service. Now, I want to consider this problem, the solution of this problem on the board, rationalization of a general surdic expression. Now, if we are given the surdic expression, if we are told to rationalize 1 over the square root of 2. Now, this is very simple to handle because to rationalize this, we need to multiply the numerator and the denominator by surd2. Because surd2 multiplied by surd2 will give us 2. And this 2 here is a rational number. All right? Now, in this case, we can write this as 1 over surd2 multiplied by surd2 over surd2. From whence we have, now surd2 times 1 will give us surd2. Then surd2 times surd2 will give us 2. If you observe carefully, you see that this denominator is now a rational number. But if we are given the case as in the board, how do we go about rationalizing this? Now, you may have an idea. You may say, okay, let's multiply the numerator of this expression by the nth root of 2 and also the denominator by the nth root of 2. If you do that, you will get the wrong answer. You'll be absolutely wrong. So the question now is, how do we make this expression and the denominator become rational? Now, this is how you go about it. You suppose that there is a number x. You can say suppose that there exists, this symbol is for there exists an x in the set of real numbers such that 2 to the power x multiplied by the nth root of 2 is equals to 2. So let's suppose that such an x exists, that if we raise 2 to the power x multiplied by the nth root of 2, the result will be 2. Let's suppose that. So we have to look for the value of such an x, all right? Now, from indices, this expression over here can be written as 2 to the power x multiplied by 2 to the power 1 upon n. And this equals to 2 to the power 1. Can you see that? Then we can manipulate this further, or we can write this as 2 to the power x plus 1 over n equals 2 to the power 1. Now, since the bases are the same, we can equate the indices or the exponents. So on equating exponents, we have the result as x plus 1 over n equals to 1. From whence we have our x equals to 1 minus 1 over n. And this fraction can be simplified as n minus 1 over n. So that means the value of s that will make this expression to work is n minus 1 over n. All right? So in the place of x, I will be putting n minus 1 over n. All right? So let's go back to the solution. Now that implies that 3 over the nth root of 2 is equal to writing 3 over the nth root of 2 multiplied by 2 to the power of x. But don't forget, the value of our x is now n minus 1 over n. So I can come here and write n minus 1 over n divided by 2 to the power n minus 1 over n. Can you see that? All right. Now, 3 times 2 to the power n minus 1 over n will give us 3 multiplied by 2 to the power n minus 1 over n. All right? Over, then the nth root of 2 multiplied by this expression will give us 2. You can check it out. Let's check it out and see whether we are right. Now we have 2 to the power 1 over n to be this, all right, to be this. Then multiplied by 2 to the power n minus 1 over n. From the laws of exponents, we have this as 2 to the power 1 over n plus n minus 1 over n. Can you see that? Then on adding numerators, we have the result as 2 to the power 1 plus n minus 1 over n. From whence this will cancel out with this. All right? So we have our result as 2 to the power of 1, which is 2. So we are right. Can you see that? So this has justified the method. So I will erase this from here now. So I will continue the work. So this is a final result. This is the final result, all right? Now, this cannot be equally written as 3 multiplied by the nth root of 2 to the power n minus 1 over 2. So by this approach, we have succeeded in rationalizing the denominator of this particular surdic expression. And this holds for any number n. It can be 2, 3, 4, 5, and so on. So I've come to the end of this particular video. Do me the favor to like, share, and comment on the video. And also, don't forget that I offer an online math tutoring service. If you need of this service, be very free to get across to me, because I will illuminate you in the aspect of mathematics. Thank you very much for being with me. I do really appreciate you all. Bye.